All right, nice. So you want to take a look at integration. For those who remember differentiation, integration is the reverse. All right. So I want to show you how to integrate. For those who miss differentiation, one of the uses of differentiation was being able to find basically a real simple application. That's differentiation. One of the basic things that we use differentiation for was the gradient, right? So we end up with a function in the form of dy dx. You don't know too much about it now. All I want you to know now is that in order for us to get dy dx, we had to have the equation of the line. So if I differentiate this, I'll get this. But now we are going to do the reverse. We are going to go from here to here using something called integration. That's okay? So that's how one through the differentiation. Remember that integration is the opposite. Okay? And for the first time in the world, I will show you how to do it. So just make a note of why we do integration. We do integration to go in reverse, to go from the gradient or dy dx back to the original function. Okay? Have some other uses as well to find area and things. But just make a note of this so you have an idea of why we're doing integration. This is one of the reasons we do integration. Okay, so we use integration to go from dy dx back to the original function. How easy it is? What we do differentiation again? Multiply and subtract. So in integration, what are you going to do? Add and divide, right? So in integration, we're basically going to add and divide. Right? Online, you'll see the whole code, right? Nice. Let me see it. Right, so let's how to integrate. Right, so if I give you a function like this, here's how we integrate, right? To be able to integrate, I'll give you something like this. Let's say I said, I want you to understand symbols as well. Let's say I said to integrate, that is symbol for integration, is an elongated S, right? The long S, okay? Right, like a little straight and then two little curves there. That is symbol for integration, right? This means that you have to integrate. So if I ask you to integrate something like this, ax to the power n, I'll put values in a little while, right? If I ask you to integrate this, with respect to x, right? This is all you have to do. I'm going to integrate. So once you integrate, take this symbol off. Okay, right? Take this symbol off, and you'll end up with ax to the n. We're going to add 1 and then divide by that new value. Right? We add in a constant here. I'm going to explain why later on. For now, just write plus c every time we integrate. Okay? So here's a small example. Here's a small example. If I ask you to integrate 3x squared with respect to x, what does this say? This tells you that the variable we're using is x. That's all it's saying, right? So don't let us confuse you. This just tells you that the variable we're using is x. How do we integrate this? Real easy. Write back 3x, add 1 to the power, and divide by that new power. And write plus c. That's it. Finish. Cancel the 3, and you'll end up with x cubed plus. Okay? So the integral of this is this. For those who can differentiate this fast in your head. You getting this? Right? So that's how we can check it, right? Oh, wait, we can know this. Okay? So that's the way you integrate. Add and divide. That's all you have to remember for now. Okay? Copy it down and just try one from online. You're okay? Felicia, Isaiah, are you okay online? Yeah. Right. We still be doing integration. We did this as I said. We have integration, kinematics, and start to do. Then we start syllabus over, right? We should finish line of November and then we start with. I remember I time during the week after practice as well, right? Tuesdays and Thursdays. They come after school and practice, right? Starting this week. Well, it's a come Tuesday. It was here Tuesday. Nathan, I was you. For the next week. Right, so you can highlight what you're doing here, right? Add and divide. Today will be nice and easy, right? Right. Excellent. All right. Okay, good. Number two. Okay. Oh, yeah. Try number 2 pass. right? So here we should have 4x. What to do here? Add 1 to the power and then divide by that new power. 3 plus 1 is 4. The 4 will cancel and you put your plus c. So you end up with x to the 4th plus c. Watch this here. Once you add and divide, you have to remove this symbol. Don't write it back here, right? This symbol just telling you that you have to integrate. Okay? So don't write back this symbol here. Try this one here. 2x dot dx. Take your time with this one. It's not tricky, eh? You just remember something. Integral of 2x. Ready? Try you get this one. Right? What does 2x mean? X to what power? X to the power of 1. Nice. So this will be 2x to the power of 1 plus 1 all over 2 plus c. 2 will cancel and you'll get x squared plus c. All right? Okay, I wanted us to, anyway, before I tell you why we do plus c, right? So here's the problem. All of these here have x, right? I want to give you something like this. Integrate 5. What do you think is the integral of 5? If I write your answer in pencil and a password, I want to take a look at what you have. Right? Online, what do you all think is the integral of 5? So those who did differentiation, think about being able to differentiate your answer to get back 5. Okay? Always remember, if I differentiate this, I'm supposed to get back this. Okay? So those who can differentiate, think about whatever answer you write. If you differentiate that, it will get back 5. For those who didn't do differentiation, think about what power of x I am going to write here so that I still have 5. Think about it. If you can't think about it, I'll show. Very good. Right answer so far. That's about 4 right answer so far. All right, so I see a few answers online. Anybody have anything? What do you think is the integral of 5? Let me see if I get anything from online here. Some people saying 5x something, right? Sebastian saying that, I'm saying that, yeah, well, they might be right. And that's correct. 5x is the answer. Here's why. We have 5 here, right? So in order for us to put back an x term here, we'll have to put that x term to the power of 0. Right? Anything to the power of 0 is 1. 1. 1 by 5 is 5. Right? Now we can integrate this. It will be 5x to the 0 plus 1 all over 1 plus c. So the answer is 5x plus c. That's okay? Right? And check the differential. The differential of 5x is 5. Are you okay with that? Right? Now try this full question here. 3x, you don't always get a nice number. You might get fractions, right? Actually, let me give you all nice number. Nice number, nice here. She's come here, you know. She's the master. Sure, same. Right? And do me a favor. Integrate this whole thing. And you're doing the same thing, right? You're doing the same thing. Integrate this, and then add a plus c at the end. I'm going to explain why we have plus c now. Yeah, piece by piece. Right? I want you to always remember whenever you integrate, your term should get larger. Okay? Integration makes larger. So you'll recognize that this is bigger than this. The terms always get larger, bigger. And magnitude. Online, you're okay? Right? So you're integrating just like what we did before. You're integrating this, just like what we did before. And you're integrating this, just like what we did before. Okay? All I did here is I just put them together. All right? Let's see what you got. The integral of 3x squared, that'll be 3x squared plus 1 over 3. Right? Don't write plus c. You only write in 1 plus c at the end of the whole thing, right? The integral of minus 4x, and 1 divided by 2. The integral of 3 is 3x. Then you write plus c. Simplify it, 3 will cancel, you'll get x cubed, 2 into 4, minus 2, 1 plus 1 is 2, plus 3x plus. Are you okay with this? Anybody confused? Are you okay? Are you okay? Yeah. Right. Online, you're okay? All right, yeah, are you good? Right. Just one thing I want to show you. Why we keep writing plus c. For those who remember, can you do me a favor? Can you differentiate this for me, please? Differentiate this. The differential of 3x squared is what? Differential of 2x's. Differential of 1 is 0. That's okay? Now, integrate this. Integrate this. You will get 6x 2 over 2 plus 2x. Correct? So this is 3x squared plus 2x. This good, this good. But what happened? There's no way to get that 1 as yet, right? So the reason we keep writing plus C is to cater for that one. So when they give us information, we can go back and find it. That's okay? That's the reason why you have plus C. Right? A constant may have been there or may not. Are you okay with that? Yeah. So the reason that we keep writing plus C is that sometimes the original equation that we had differentiate had a constant. Right? So we put in plus C in case it had one. Because if it didn't have one, then C would just be 0. Right? C would just be 0. Are you okay with that? Okay. Next one. Which formula? That one again. Yeah, send me WhatsApp or send it full time. Okay. All right, so of course it will come this easy all the time, right? Sometimes it look like sometimes it look like this. There's no quotient rule for integration, right? What you would do here to be able to integrate this? Anybody? How you will integrate something like that? There's something you have to do before you start to integrate. Everyone to guess? Anybody online? Anybody? Right? So what you have to do is simplify the indices. And this is x to the power of 1 here. So you'll end up with the integral of 4x to the 1 minus 3. Notice I did not integrate as yet, so I'll leave in the integral sign on the outside, right? All I am doing is simplifying here. And I'll get the integral of 4x to the minus 2. That's okay? Can you integrate this now? Yeah? Go ahead, have fun. Of course, I can't give you a question without giving you a square root, huh? So as it move along on here, I don't know if I'll pick up this book and revise, right? But let me just say it is do that. Should make a little note here, simplify the indices. Okay? So when it going through your notes, it might you will see it. So if you see it again, the question you know what to do. At this possible on a file page, just put in it, only add your number and not only WhatsApp. Right, apartment around, just put your name, if you're not on the WhatsApp group for Almas, put your number. Oh, today, I'm not now, before it immediately. Immediately. Elements, yeah, we'll fix that next and make sure you're done something. Okay, well, they'll put up. Yeah, I'm adding you on first to make sure it goes in and I'll add it to that. Okay? Everybody okay? The integration that, right? So what's the integral of this? Notice again, I did not integrate as yet. Only when you add and divide is when you start to integrate, so you can take off the integral symbol. Okay? So I'll end up with 4x to the minus 2 plus 1 over minus 1. So I'll end up with minus 4x to the minus 1 plus 2. Right? Because I gave you your answer as a fraction, it's a good habit to give them back as a fraction. If you're not seeing it, you can look here, right? So if you want to break in it. Right, so your answer will be minus 4 on x plus. Okay? Right, those only cast, right? If you can't see here, you just look up, right? Yeah, put your name, but if you're not in the group, put your number as well. For it. Not in 2 seconds. Every time, what is it? Try 7 and 8. Isaiah, your weekend. Right, everybody, yeah, when I build the group, I'm going to send you back in summary, right? I want you to review the summary for 2 topics for next week. And I'll tell you why, right? I'll tell you which topics on the group. Just learn about these basic rules for whatever. With that. Take your time with number 8. Same principle, you see what you do. Try something or don't leave it blank. Try something with number 8, right? In a short comma, I'll check it. Yeah. Last minute. All right, ready? Let's see how it looks. So here, first step. First step is the 3 minus 5, right? So that'll be x to the minus 2 with respect to x. When we integrate, minus 2 plus 1 all over minus 1 plus 2. So you'll end up with minus 3x to the minus 1 plus. Okay? Because I gave it as a fraction, write it back as a fraction. Are you okay with that? Right? This one here, I saw some people tried it, but I want you to remember this, right? What is this saying? This is saying 3x squared minus 2x all divided by x. Okay? So it really saying this. It really saying the integral of 3x squared over x minus 2x over x. Okay? So x has to go into this and x has to go into this. Okay? Not one of them alone. Both of them. All right? X into x squared, that'll be 3x, x into 2x minus 2. Right? Now you can integrate. The integral of 3x is 3x squared over 2. Integral of minus 2 is minus 2x. You okay with that? Everybody okay with that? So you had to divide both of them by x. All right? As the keyboard and mouse it out. But still have to do it. I'll show you. You know how to give you a little square. Have to give you a little square. Actually, to make it a little complicated and father. Right. I got a name here, right? All names here, right? The right name here, right? So just these numbers I'll add to the compile group, right? Right. How we handling this? What does square root mean? Square root means to the power of a half. Right? Square root means to the power of a half. I'm gonna pass you over this. Right? So x, all we have to do, add 1 to the power, divide by that new power, plus c. So this is x to the 3 on 2, all to the. What do you do with a fraction underneath if you want to bring it on top? You can flip it over and bring it on top. Right? So flip over. Huh? Yes, we said that over. Right? Right. So this 3 on 2, I can flip it over and bring it here. Okay? Anything you have in the denominator, you want to bring it up, you just flip it over and bring it on top. Right? So I'm going to flip over 3 on 2 and I will get 2 on 3. Plus. That's okay? But I gave you the answer as a square root. So I want you to give me back as a square root. Right? What does x to the 3 on 2 mean? It means x cubed multiplied by a half. Correct? So a half is square root. So the answer can be written as 2/3 by the square root of x cubed. Plus. Right? You get lost there? I'll show you again. Are you okay up until here? No? Yeah? All I did is I took the 3 on 2, I flip it over and I bring it on top. Yeah. That's a rule you can learn, right? Are you okay with this? Yeah? So you bring your rules here. All right, so good. What does 3 on 2 mean? 3 over 2 means x cubed by a half. 3 by a half is this. Correct? Yeah, okay? No? You're okay with this and this being same thing? And a half means what? Square root. So I put the square root of the whole. Okay? You have to learn to get back the answer in the form they gave you. Okay? I'm gonna give you one more with a little square roots. Gosh, I have to give you a square root. I have to, I really have to. All right. One thing I want to show you about integrals, right? Is what you say. If I give you a constant, right? You could take that constant and bring the constant outside and follow the same things. Okay? That's something that you can do with integral. It's a feature of integration. You can take the constant and pull it outside. So if a constant multiplied by the whole function, you can put it outside. Right? I'll be using that later on. But you don't have to do it right now. You could do it to make it simpler. Right? Yeah, just do the same. I'll show you. If you take out the 3 here, and it's exactly like that. So leave here, right? But you don't have to. Let's see. Go ahead, just try back down there. Yeah. Yeah. No, it'll be out here. I'll be out here and cancel. Right? Right, so we should have something like this, 3 by the integral of the square root of x dot dx. And we work out this already, right? And we know the answer is 2/3 by x cubed plus c. Right? You can multiply it out by 3, this will cancel, and you'll get 2, and you can multiply 3 here as well, plus 3c. Right? You can do it like that. Actually, by the way, put the plus c out. Put the plus c out. Right? So sometimes by pulling it out, it makes it look a little easy. Not all the time, sometimes. All right. I can make it harder now. Yeah. Right here, because I integrate this, the integral of this is this. So I multiply this alone by 3. And then I put the plus c outside. If you work it out later on, you'll still get the same answer. But for now, leave it like this. So work out this, which is this, and then add the plus c out. Right. Do I make it complicated? I want to show you the calculator. The calculator can integrate here. Right? The calculator can integrate, but it can only give you a value. So it will not give you a function. I'll show you what I mean just now, right? Right? When you finish like that, take this small note. Take this small note. All of the integrals above. All of the integrals above. All of the integrals above are called indefinite integrals. Indefinite, one word, right? All of the integrals above are indefinite integrals. All right. So everything that we did before, indefinite integrals. Now we are going to focus on definite integrals. Okay. So have definite integral. Right? Kind of definite integral. Online, you're okay there? All right, all okay? Crystalline. Yeah. Right. So what is a definite integral now? A definite integral is one that will give us a numerical value, not a function. So you won't have any x, you're going to get a numerical value. And here's how it looks. Right? If we have something looking like this, we have limits. Limits means that we're going to have values here. Right? And I want you to note that b is always bigger than a. Okay? if I give you something like this, all you have to do is integrate just like normal and plug in B and minus the value you get when you plug in A. So basically you're doing this. Integrate, plug in the P value, work it out, plug in the A value, work it out, and then minus it. And you'll get a numerical value. That's okay? When you get a numerical value, those are definitely identical. That's it. Okay? I'm gonna show you an example. And this could be done in the calculator, so you can check back the answer as well. Let's say I said integral between 2 and 1 of 3x squared. Right? Watch how easy it is, right? Real easy. All you have to do is to integrate 3x squared. Right? Integral of 3x squared, you work it out a few times, that's x cubed. Right? Watch this here. All we have to do now is follow a line, put your 2, put your 1. This line tells us that we already integrate, but all we have to do now is plug in 2 and 1. So you're going to get 2 cubed minus 1 cubed. 8 minus 1 is 7. That's it. Okay? That's all you have to do. Integrate, plug in 2 and 1. Now, if you have a shaft, you can't do it, so don't bother, right? Start your right. If you have the shaft right view, you can do it. Casio, what you have to do to work out this, you come here to the integral sign right under this menu. Press the integral sign and put in the function. Put in the function 3x squared. So put in 3, there's an x out here, and then put squared here. Squared. I just put squared here. Yes. I just put squared. Your square button now again. Oh, right, yeah. Those who online, press the integral, press 3x, there's an x on the right hand side here. Right, then squared, and then go back and put in the limits, right? The limits is be a little tricky to put in 1 and 2. Right? And then press equal. And you'll get 7. Okay? Right? The x you're using is this x here, right? This only works if you have definite integrals. Huh? If it's indefinite, it will not work. Huh? So please, if you're doing advanced invest enough, Casio. And it's like it's are you okay? Yeah. So we can do it both ways, right? Online, you'll figure out how to do it. If you don't have a Casio, well, don't worry, right? But if Casio will give it this value, you cannot go from here to here in exam, you'll get 0. Okay? The reason I'll show you is just to check back the answer. All right? Right, let's combine everything we did today. Try that, please. Huh? That's easier. Book it out and then go to the calculator, try it. No, no, that is not happening. Higher one else. Business only, then you can make it. Higher one, lower. Online, everybody must chance of it for this, right? Everybody. Someone jump over there. Who's your side? It's icy, I'm going again. With the time and simplify it and then plug in your values, right? Plug in 2 and 0. Okay, so remember x into this, and x into this. Okay. You all recognize that I'm not putting in this C value, right? Anybody knows why? Yeah. Why am I going this C value there? Ah. See that the different values. They'll put it in the calculator properly. Right, so let's see what you have. The integral between 2 and 0, x into 4x cubed, 4x squared, x into 6x squared, 6x, x into minus 2x, minus 2. Okay, now we're going to integrate. So I'll end up with 4x cubed, because I added 1 to the power, divided by the new power. 6x squared, I divided by the new power. And the integral of 2 is 2x. That's okay? So now, what am I going to do now? After I integrate, what to do now? Chris, what to do now? After you integrate and you have these values, what you supposed to do? What I did here? I plug in 2. And I plug in, sorry, I plug in 2 here. And I plug in 1. So I get 2 cubed, 1 cubed. You okay with the integral step? Right. All we're doing now, whenever you definite integrals, you're plugging in the values. So after I finish it, let me write it a little bit nicer. This is 4 and 3x cubed minus 3x squared minus 2x. I am leaving out the plus C and I'm going to ask you why just now. Right. When you reach here, all this means is that I have to put in 2. I have to put in 2 here. So I'll get 4 and 3 by 2 cubed minus 3 by 2 squared. Right? Work out that value. Work out that value. And then minus plugging in 1 here. So putting in 1, I'll get 4 and 3 by 1 cubed. 3 by 1 squared minus 2 by 1. Where? Sorry, I changed it. Sorry. 0. Thanks. Follow what it? I just integrate and I plug in this, work it out. Plug in this, work it out, then minus. That's all I'm doing. Right? So once you understand this, that you have separate. Just to get used to dealing with this. Put in the 2, work out the answer. Put in the 0, work out the answer. Okay? So some of you are getting some difference. I have 2 cubed is 8. 8 by 4 is 32. This is 12. Yeah, this is 12 minus 4, so that's minus 16. Right? 16 by 3 was that 48. So I am getting minus 16 on 3. Oh, you got a long way. Yeah. Going back over time why you're confused. Forget the working out part. You're okay with the integral? And when you give the integral, yeah, and when you give the integral, after the integral step, all you're doing is plug in 2, work it out. Plug in 0, work it out. All right. Are you okay with that? Right? We continue right here next week. We'll practice some more. But from today, I want you to understand how to integrate. How to integrate first set of questions. Right? Next week, we'll spend more time doing second-type integral. Right? And before we go, why am I not writing plus C anymore? Anybody? Anybody get it right? No homework. Why am I not writing plus C anymore? I'm not bothering to write plus C here. And I'm writing plus C here or plus C here. No. Something else. Anybody? Why am I not bothering to write plus C anymore? Well, again, close. Yeah, doing face to face. Same thing before. Yeah. Yeah. Right. Just imagine, right? What you see here. Easy, not something easier than that. If I write plus C here and I write plus C here, what will happen? But what will happen to the plus C from here and the plus C from here and a minus sign in the middle? Cancel out, right? So that there is no need to write it. Okay. All right. All right. So that's it for today.